was being pushed to produce high intensity beams. Alright, it was working, but we needed high intensity beams in our system. So when SPS was pushed to do that, and then we saw that there was breakage of the wire again. So the wire broke down, there was damage in the wire, and the detection was that actually that wire that was being used in the scanner, it was working in the antenna. As the antenna, and it was producing the same radio frequencies that was observed in 2002. So, and they saw that, we can see that this is the, this beam here is the normal, like the beam profile before the wire was damaged. This is the normal distribution of the beam, and this is what it showed before. And this is when the wire actually broke down. The wire failed after this detection, this interaction. And these two plots, these are after the breakage of the wire and after the wire was failed. So this was observed in 2012. So we can see that this is actually the high current, very high value of the current that was produced in the wire at that time when it failed. So this is because it happened, and then the solution to this problem was proposed that we used another tungsten wire, like the wire that is going to interact with the beam is here, carbon wire, and another tungsten wire is attached here. So what happened that the radio frequency modes traveling down the lengths of the device will actually get absorbed by this tungsten wire here. So it was used to damp out the radio frequency modes that were actually traveling from there to the tanks of the detector. Another thing was done that extra aluminium plates were installed inside the tanks to do the same thing. Like they were there to oppose the radio frequency modes, and they were there to absorb the radio frequency modes, so they don't interact with they don't get into the tank of the scanner, so they don't interrupt all the detections afterwards. So it was done back then. So in 2012, this is the few data that is showing that this is in the scanners, in the following scanners, this is the how many times we get to have the breakage of the wire, the damage in the wire. In this scanner, it happened like a beam-induced failures by like 2 times it happened, and then 1 time in 519H and 519B. 1 time it was a constant, and the mechanical failure was seen in 590H in 2012.
Yes, ma'am.
So, there are a few of the micrographs that are showing that this was the carbon wire before, and this is how it got sublimated after its interaction. Like after its failure, it was sublimated and only the core of the wire remained there. This is what happened to the wire at that time. Another issue that was happening, the wire was getting damaged. Like the interaction with the beam, not only the sublimation, but the damage of the wire was also one of the reasons of the failure of the wires at that time. So it was seen in 2012 back then. So now let's talk about the selection of the wire. That how should we select the wire that is going to be used as the like in the scanner for the interaction of the wire with the beam. So here is a table that is showing a few of the properties that we need in that wire. Not the properties, but the geometry of the wire that we need to be there. Like in the proton synchrotron booster, the diameter of the wire should be 24 micrometer, and in the proton synchrotron, it must be 24 micrometer here as well. And in the super proton synchrotron, it must be 34 micrometer. And the wire length must be 120 millimeter, 153 and 153 in both of these equipment. And the fork length on which the wire was installed, it must be like 150 millimeter and 183 millimeter in both of these equipment. It is just about to give you an idea of the geometry of the wire that is needed. So before wire scanners being used in LHC, there were so many materials, there were so many elements that were used as the wire. But we selected carbon to be the best, and I'll show you there are a few steps that material needs to, there are a few criteria that material needs to fulfill in order to get selected as the material for the wire. So in the past, before using an LHC, carbon, tantalum, beryllium, steel, quartz, titanium, tungsten, all these things, they were being used as wire So